So guys, we are doing exercise 4, question number 13. Okay. Limit x approaching towards 0. Cube root of 1 plus x minus cube root of 1 minus x upon x. Now the problem seems to be rationalization, but then this is not rationalization because it's not a square root, it's a cube root. Okay. So x approaching towards 0, 1 plus x raised to 1 by 3 minus 1 minus x raised to 1 by 3 upon x. Okay. So limit x approaching towards 0, 1 plus x raised to 1 by 3. I'll subtract 1 and then I'm going to add 1 and then I will add 1 as well upon x. Okay. Now this x, okay, by the way, prior to that, we did this because the formula is x raised to n minus a raised to n upon x minus a. So this one and this one will be written as 1 raised to 1 by 3. And for the next term, this term will take a bracket so that this becomes minus. Okay. Yeah. So that's that 1 raised to 1 by 3 minus 1 minus x raised to 1 by 3 minus 1 raised to 1 by 3. We took a bracket, this became minus. Okay. At the same time, I'll split that x which was there in the denominator. Okay. This x I'm splitting. So limit x approaching towards 2, 1 plus x raised to 1 by 3 minus 1 raised to 1 by 3 upon x. Okay. Minus limit 1 minus x raised to 1 by 3 minus 1 raised to 1 by 3 upon x. Okay. Limit of the first term minus limit of the second. I never write this because it is understood, but then in this problem it is quite required. Okay. Now see this. This is plus x and this is plus x. So really not a problem. This is minus x. So we'll have to make this minus x. So for that reason, I'll take this minus over here. I'll make this plus because the denominator should be minus x. Okay. So limit x approaching 0 upon x upon minus x. Okay. Now this is 1 plus x. So I'm going to add 1 and I'm going to subtract 1. And this is 1 minus x. So I'm going to add 1, I'm going to subtract 1. The next step. Okay. I'm writing one more step for you. Limit x approaching 1 by 1 plus x raised to 1 by 3 minus 1 raised to 1 by 3. 1 plus x minus 1 plus limit x approaching 0. 1 minus x raised to 1 by 3 minus 1 raised to 1 by 3 upon 1 minus x minus 1. So I'm adding 1, I'm subtracting 1. Now I cannot apply this formula x raised to n minus a raised to n. Still I cannot apply because this x should be same, which is not same basically. And a should also be the same in both the limits, which is not same. Okay. So right now we cannot apply this formula. We need to do something more over here. So x approaches 0. So add 1 on both the sides. 1 plus x will approach 1. X approaches 0. So this is 1 minus x. Okay. So minus x will approach minus 0. Minus 0 is nothing called as minus 0. It is 0. It is multiplication with minus 1 on both the sides. Now add 1 on both the sides. Okay. So x approaches 0 means what? 1 plus x approaches 1 and 1 minus x also approaches 1. So limit 1 plus x approaches 1, 1 plus x raised to 1 by 3 minus 1 raised to 1 by 3 upon 1 plus x minus 1. Limit x approaches 0, 1 minus x raised to 1 by 3, 1 raised to 1 by 3, 1 minus x minus 1. Okay, so this is x and this is a and this is n. Now we can apply the formula. Okay, randomly don't apply the formula anyhow. The term should be same. So n a raised to n minus 1 plus, okay, I forgot to write this over here. X approaches 0 means what? 1 minus x approaches 1. Okay, so here also x is same. So x is same, a is same, n is same, minus n minus n. And denominator does not have power. Okay, so 1 by 3, 1 raised to 1 by 3 minus 1, n into a raised to n minus 1. Okay, now this will be 1. The thing which I've marked in orange is 1, 1 raised to everything is 1. So this will be 1 by 3 plus 1 by 3, which is equal to 2 by 3. Fine. Do this problem.